So let's go ahead and look at the factor theorem. That's what this is saying. The binomial x minus r is a factor of the polynomial p of x, if and only if p of r, or the remainder, is 0. That's what that means. P of r equals 0, the remainder is 0. And it tells us that x equals r is a 0, you can also say x-intercept, of the original polynomial p of x. Again, we get x equals r by taking x minus r equal to 0 and solving. Move the r over, we get x equals r. All right, well, let's practice that. Okay, it says, the next example says divide this cubic, 2x cubed minus 3x squared plus x by x minus 1. State whether the binomial is a factor of the polynomial. Well, it's a factor if the remainder is 0. So let's use synthetic division. One. It's the opposite of the number we have here. 1. Bring down the coefficients. 2. Negative 3. 1. Okay, we have a small problem. 2, negative 3, and 1 are the only coefficients that I have. The degree is 3. I should have 4. Where does the fourth one come into play? Well, we don't have a number on the end of it. There's usually a number add or subtracted to it. We have to put a space holder for that number. So we put a 0 on the end. Again, if a term is missing, we must use a space holder. So you must put a 0 on the end. We can now complete this synthetic division. 2 multiplied by the number in a half box is 2. Add vertically. Negative 1. Take that times the number in a half box. Negative 1. Add vertically. 0 times 1 is 0. Add vertically. The remainder is 0. That is big time. That tells us that x minus 1 is a factor of 2x cubed minus 3x squared plus x. Also, it tells us that x equals 1 is an x-intercept of 2x cubed minus 3x squared plus x. Well, we also have a quotient here of 2x squared minus 1. Sorry, x. 2x squared minus 1x. Or we should just say 2x squared minus x. How is that used? Well, the quotient is also a factor of 2x cubed minus 3x squared plus x. Okay, that's also a factor. So we can actually say that two x cubed minus 3x squared plus x is equal to what we divide it by, x minus 1, times its quotient, 2x squared minus x. And if you notice in our quotient, there is an x we can factor out. We could completely factor this by taking the x out, putting it out front, which leaves us with 2x minus 1. So we have completely factored a cubic. Now that one we may have been able to get away with by originally factoring out an x, but they're not all going to work that way. It's a lot of information for just two little theorems. Remainder theorem really allows you to break things down. This is definitely going to be used in calculus next year. I've already helped a couple of calculus students out that have forgotten about this, so please try to get this into your head and make sure you remember it for next year, because when we're breaking down rational functions, maybe we have a cubic over a cubic, okay? We want to study it the same way we studied it earlier this year with finding vertical asymptotes, finding maybe if something cancels out, which would cause a hole in the graph, all right? Eventually breaking it down to something smaller where we can determine end behaviors, which might be a horizontal, it might be a slant asymptote or something like that. Okay, so this is very useful with all of that. When we get to the higher level polynomials being divided with rational functions. All right, so I think we have one more to look at. We're going to do this one more time. We're going to break it down completely. That's what we're doing. We're breaking down or factoring higher level polynomials, in this case cubic so far. And here's another cubic that we're going to factor. Determine the binomial factors of x cubed minus 7x squared plus 6. And as you can see, this cubic, there's nothing to factor out. The last one we could have factored out an x to begin with, but not here. Also, the thing that's different about this is we're not being told what to divide by. So we have to determine what we should be dividing by. What x values should we be putting into the synthetic division? Well, there's actually a way to do that by hand. It's called the rational root theorem, and we're going to study that in the next section. For right now, I'm just going to show you a little bit easier way, but it does cause you to rely on the graphing calculator. Okay, if you remember, we go back to the factor theorem. I said that x equals r is a 0 or x-intercept of the polynomial. So if we can figure out what the x-intercepts are, we should be able to tell you what the factors are and algebraically prove using synthetic division, hopefully getting a remainder of 0, that those are the factors of the cubic. So we're going to use a graphing calculator to do this. After we know the rational root theorem, we won't have to use a graphing calculator anymore. So let's go ahead and graph this. X to the third minus 7x plus 6. I'm also going to set y2 equal to 0. Okay, the reason why I'm setting y2 equal to 0 is because there's a very easy way to find x-intercepts with a graphing calculator. Okay, and that's using what's called the intersection function. And y equals 0 is putting a line on the x-axis. So, when I graph these two, if I can find the intersection of the y sub 1, the graph, with the x-axis, which is what I'm saying y sub 2 equal to 0 is, then we should be able to very quickly and easily find the x-intercepts. So let's go ahead and start with the zoom 6. And we can see there's 1, 2, 3 x-intercepts. Second, trace, which is a calculate menu. Number 5, intersect. Now, we're going to move the x, the blinking spider, whatever you want to call it, dancing spider, blinking x, as close as we can to one of those x-intercepts. And we're going to hit enter 3 times. It's not a left-right thing like we did with max and mins. It's very simple. You pick a first curve, pick a second curve, and hit enter on guess, and it will find it. And it's telling us that x equals -3. Works. And we'll do it again. Second, calculate, trace, intersect. Again, we move the spider over, hit enter 3 times to the next one. X equals 1. And let's see what that last one is. Again, getting close as possible. x equals 2. Now, we're very fortunate here. I will tell you right now, in most cases, you will not get all 3 to be nice. By the way, 3 is the most we could have because the degree of the polynomial we're looking at is 3. That tells us there are 3 complex roots, okay, or 3 complex zeros. All of them are real, and all of them are nice. Usually, you might get one nice one, maybe 1 or 2, but usually 1 nice, and the rest are really ugly decimals. And those ugly decimals come from square roots. So we're very fortunate here. We have 3 nice ones. We're not going to use those 3 to break down this polynomial synthetically. So we're going to start with -3. We're going to bring down the coefficients of 1. I have no x squared term, so I have to put a 0 placement. It's -7 and 6. So 1. 1 times the number in a half box, -3, vertically add. -3 times -3 is 9, vertically add. 2 times -3 is -6, 0. That's perfect. Remainder is 0. That tells me that x minus 3, the opposite of that, x plus 3, is a factor of x cubed minus 7x plus 6. Also tells me that x equals -3 is an x-intercept. We already knew that, though. That's how we found this. Okay, so we can move the -3 over, and we can say x plus 3 is a factor. Now, instead of redoing this completely and using the original, why not use the quotient? Okay, so we're going to use the quotient to break this down synthetically. So I'm just going to put another little half box right in front of my quotient. I'm going to put the next number in, 1. And I'm only going to do this to the quotient. The remainder is gone. It's no longer important. So we bring down to 1. 1 times 1 is 1. Negative vertically adding, we get -2. Multiplying, we get -2, and 0. And I'm done. That tells me, okay, since the remainder is 0, okay, that tells me that x minus 1 is a factor of x cubed minus 7x plus 6. And it also tells me what I already knew, that x equals 1 is an x-intercept. So x minus 1 is a factor as well. Now, what we have left, the quotient that's left over, we went from 3 to 2 to 1. The quotient that's left over is actually just x minus 2, which happens to be the factor we get from this x-intercept. Again, when I broke this down earlier, I told you that the quotient is also a factor. So we don't even have to do the synthetic division after we go far enough. Okay? We can simply say that x minus 2 is a factor of x cubed minus 7x plus 6. And we can say that x equals 2 is an x-intercept. Which we already knew. So let's rewrite this. X cubed minus 7x plus 6 is equal to x plus 3 times x minus 1 times x minus 2. Those are the 3 factors that we found. We completely and totally broke down this cubic. And if we didn't have the calculator to tell us that those worked, using the rational root theorem, we could find ones that did work and then prove that synthetically, or I should say find possibilities of zeros or x-intercepts that would work. And then once we get ones that gave us a remainder of 0, we could then show that without the use of a graphing calculator. So that's what we're going to do in the next section, is to start breaking these down without the use of the calculator. Again, I like technology. I think it's useful. Probably still going to have you confirm your answer with the graphing calculator. Okay, it's always good to confirm your results. But we are going to show you how to do it without the calculator. That's all I have for you today.